This is Patrick Dolans with another PowerPoint presentation continuing in our first model series. As you'll recall from the last presentation, we were focusing on wine and salmon production in two locations, Washington and Oregon. In this presentation, we're going to calculate the opportunity cost for each activity in each location. We'll start with determining the opportunity cost of wine production in Washington. In each of these exercises, we want to focus on the per unit cost. That is to say, when we ask what is the opportunity cost of wine, we want to know what sacrifice is involved to get one additional wine in the state of Washington. To make this calculation, we need to revisit the productivity information that we used in the last presentation. As you'll recall, in Washington it takes 1 hour to produce a bottle of wine and 15 minutes to catch a 1-pound salmon. That means in the state of Washington, each hour that is required to produce one additional bottle of wine could have been spent fishing and would have yielded 4 salmon. Therefore, the sacrifice to get an additional bottle of wine, or the opportunity cost of one additional bottle of wine, is 4 pounds of salmon. That fills the first cell in our table. Notice that the units for opportunity cost are not what you would expect. In fact, we're measuring the opportunity cost of wine in salmon that was sacrificed. The next question is to find the opportunity cost of salmon in the state of Washington. If we revisit the productivity information, once again focusing on the hour that it takes to produce a bottle of wine and the 15 minutes that it takes to catch a salmon, and then think about the sacrifice involved when we choose to fish. Each additional fish requires 15 minutes of our time. What could we have done instead with that 15 minutes? Well, in this example, the only alternative is wine production, and 15 minutes would only get us 25% of the way towards one additional bottle. Therefore, the opportunity cost of one additional salmon, or one additional pound of salmon, is 1/4 of a bottle of wine. Notice that the opportunity cost information, the numbers that we just calculated, could also be derived from the graphs, and that's because the slope of the production possibilities graph actually captures the opportunity cost of the activity on the horizontal axis. Verify this for yourself using the state of Washington as an example. The 100 bottles of wine on the vertical axis was the maximum. The 400 pounds of salmon on the horizontal axis was the maximum in that activity. The slope, or the rise over the run, of this line is 100 over 400, or 1/4. And 1/4 is in fact the opportunity cost of the activity on the horizontal axis, salmon in this case. Notice you could draw the graph the other way around, with salmon on the vertical axis and wine on the horizontal axis, and you would get the slope of 4, which was the other opportunity cost. That's because within a location, the two opportunity cost calculations are reciprocals of one another. 1/4 and 4/1 are reciprocals, and that's not an accident. Sometimes you can use that information as a shortcut when you're making these calculations. Our next task is to calculate the opportunity cost of wine in the state of Oregon. To do this, we need to revisit the productivity information. Once again, in Oregon, it takes half an hour to produce a bottle of wine and 20 minutes to catch a 1-pound salmon. The math here is a little more involved than the Washington example, but it's still relatively manageable. In Oregon, the 30 minutes that are spent producing one bottle of wine involve a sacrifice of time not spent fishing. What could we accomplish in half an hour of fishing? The answer is we could catch one 20-minute fish and be halfway towards the second fish. Therefore, the opportunity cost of one bottle of wine in Oregon is 1.5 pounds of fish. The final empty cell that needs to be filled focuses on the opportunity cost of salmon in Oregon. Once again, we can use the productivity information, or this time we can use the insight that within a location the two opportunity costs are reciprocals. In either way, we come up with the same answer, which is 2/3 of a bottle of wine. That is to say that each 20 minutes spent catching a single fish, if spent on wine production, would generate 2/3 of a bottle. Opportunity cost calculations are relatively straightforward, and yet they still manage to be just a little bit tricky. Be careful, use the reciprocal test to double check your work, and don't be afraid to use your graph as a shortcut, because opportunity cost is nothing more than the slope of the production possibility line.